Hello and welcome to the answers to worksheet number 3. In the first problem, we are looking to find the probability that both are blue. So those are independent events because we're spinning here and we're spinning here. So because they're independent events, I can take the probability that the first is blue times the probability that the second one is blue. The probability the first is blue, there are 2 out of 6. Probably the second is blue that looks like 1/4. So multiplying that is 2/24, which is 1/12. And we can just leave that as a fraction, 1/12. Okay, the next one says what's the probability that they are both the same color? This one is a little bit more involved because now we want to find what's the probability that it's blue and blue, or probability that it's red and red, or the probability that it is yellow and yellow. Well, the first one we just found was 1/12. And we have or, we're going to add. The second one, we need to find the probability that the first one is red and the second one is red. Well, the first one is 3/6. The second one is 1/2. So we have 3/12 for red. And for yellow, the first one is 1/6. And the second one is 1/4. So multiplying, that's 1/24. Now we're going to need common denominators to add these together. So if we make them all 24ths, it's 2/24 and 6/24 and 1/24. Makes a total of 7 9/24. That they have all the same color. We could reduce that to 3/8 also. Once we have that, we could divide by 3 and 3. This is probably the best answer, 3/8. Okay, the third one, probability that we have a red-blue combination. Okay, so first let's do the red here and blue there. So probability that we have red and then blue, or we could have blue and then red. Okay, so let's go red and blue. Well, this one would be, the reds are 3 out of 6 times, because when we're adding, or when it's and, we want to multiply, this one is 1/4. So these two together make 3/24. This one, the blue is 2/6, and the red is 1/2. That makes 2/12. So 3/24, the or means plus. We have 3/24 plus 2/12, which is 4/24. So 3/24 plus 4/24, total of 7/24. I probably didn't leave enough room here. Problem number 4. We have 3 yellow pencils, 1 blue pencil, 2 red pencils, 2 red erasers, and 1 blue eraser. Find the probability of a red pencil and a red eraser. The red pencil would be 2 out of the 6 pencils, and we're going to multiply. 2 red erasers out of the 3 erasers. That's a total of 4 out of 18, reducing 2/9. In this problem, we've got 2 bags of candy. The first one is 70% orange, 30% red. The second one, we've got 10% orange, 50% white, 40% green. She's going to pick one bag and just close her eyes and reach her hand into one bag of candy. What's the probability that that candy is orange? So we need to find the probability. Let's see, probability of orange would be the probability, how many oranges total? There are 70%. Her probability of the first one is 70%. Probability that she gets an orange out of the first bag means that we got to go, let's see here, orange out of first. So that means that she's picking orange, and she also picks the first bag. Or she could pick orange and the second bag. So find the probability that the first bag is orange. If she reaches into the first bag that it's orange, that's 0.7. What's the probability that she actually chooses the first bag? That's 50%. Or means plus. Probability in the second bag is orange, that is 0.1. And that's the probability that she picks out of the second bag is 0.5, so times 0.5. So 0.7 times 0.5, that's 0.35, plus this is 0.05, total of 0.40. So she has a 40% chance of grabbing an orange. Okay, next one. We are spinning, or no, we are flipping and we are rolling. What's the probability that we get tails and a number less than 5? Well, the tails is 0.5, and a number less than 5, that's 1, 2, 3, or 4. That's 4 out of 6. Actually, I'll change this to be 1/2, and we'll do a 4 out of 6. So multiplying easily makes 4 out of 12, which is 1/3. We've got sections on the spinner. We've got 8 sections, 3, 3, and 2. We're going to spin twice. What's the probability that they're the same color twice? So that could be red, red, or white, white, or blue, blue. So the first one is a red. The probability the first one is a red is 3 out of 8. The probability the second one is red is 3 out of 8. We need them both to happen. They're independent events, so we can multiply. 3 out of 8, 3 out of 8. That is 9 out of 64 for the red, red. For the whites, that's the same thing. 3 out of 8, 3 out of 8. That is also 9 out of 64. And for the blues, there's only 2 blues, so 2 out of 8 and 2 out of 8 makes 4 out of 64. Now all of these are or, so we can add all those together. 9 plus 9 plus 4, that's 18, 22. Our answer is 22 out of 64. There should be a 4 down here. But that can reduce. Dividing by 2 gives me 11 out of 32. I think that's probably the best answer there. Okay, number 8. Which room has the best chance? Well, let's look at the number of ways that it can happen. How many choices, if we got this guy here and he's going to go down this path, how many total choices does he have? Okay, he's got to make a choice here. So let's look at A first. Probability for A. He's going to come here and he's going to have a choice out of 3 things. How many ways lead to A? Just this one in the middle. So we've got a 1 out of 3 chance that he chooses A. Then he gets here, and any of the choices he makes at this point are all going to lead him to A. So that doesn't really matter. He just has a 1 out of 3 chance of getting to A. Oh wait, there's another way that he could get to A. He could do this way, or he could go here and here. So if he did that, he could make this choice, which would be a 1 out of 3. This path would be 1 out of 3. And then another 1 out of 3. So if he comes here and here, that's a 1/3 chance that happens and a 1/3 chance that happens. So that's 1/9. So we've got 1/3 plus 1/9. This common denominator, that's 3/9 plus 1/9. Is a 4/9 chance of going to A. Okay? Going to B. He's got a 1/3 chance here. So either way he goes here is going to get him to B. Plus, he's got this choice and these 2 choices, which is going to be 1/3 times 2/3, which is going to be 2/9. 1/3 plus 2/9. So that is 3/9 plus 2/9 is 5/9. So probability of B equals 5/9. So that's the greater probability. So let's put our money in room B, because he's got a 5/9 chance of getting there. So here, what's the probability of going to A? Well, he's got to come here. And first he's got to make, the only way to get to A is if he goes this path straight through, right? So he's got to first make this choice to go here. That's a 1/3. And then he also has to make another choice here, and there's only 1/3 of a chance. So that gives him 1 out of 9 chance of getting into A. For B, he's got to make, he could go this way, 1/3, and that would work. Oh wait, there's another way to get to A. Oh no. Oh no, didn't see all that. Tricky, tricky. Okay, so he could get to A this way. He could go, I'm going to move these down a little bit. Oh, they're all connected. All right, well, we're going to go 1/3 here. He could go 1/3. We'll get him straight in through here. Ah, no, 1/3 times 1/3. So he's got to go 1/9. That's a chance that he's going here. He could also go here, though, which is a 1/3 choice here, and then a 1/2 choice here. So this is 1/3 times 1/2, and that's going to be 1/6. Or he could go here, which is just going to go to A. I thought before that was one I was going to C, but it's actually going to go here. So that's a 1 out of 3 chance there. So A has 1/9, come over here, plus 1/6 plus 1/3, because he could do this, or this, or this. And or always means plus. Common denominators, let's go 18. So 2/18 plus 3/18 plus 6/18. That gives us 11/18. So that is the probability of A right there. For B, he could go here and here, so that'd be a 1 out of 3. And then a 1 out of 2. So that's a 1 out of 6 chance he does this and this. Or he could go 1 out of 3 and another 1 out of 3. So he could also go 1 out of 3 times 1 out of 3, which is 1/9. We can add those two together. Probability of B equals, let's change these to 18s also. 3/18 plus 2/18, 5/18. And now C, he can only get there one way. He has to go 1 out of 3 and then 1 out of 3. And that is 1/9. If we think about 18ths, that's 2/18 plus 5/18 plus 11/18. That makes a total of 18/18. Problem 10, there's a 60% chance of rain. If there's no rain, there's an 80% chance of going to the beach. So what's the probability of going to the beach? Well, that means we'd have to be no rain, and we'd have to actually go if there's no rain. Probability of no rain is 40%, the opposite of this, and means times 80% chance of going, if that's the case. So 0.4 times 0.8 is 0.32. So there's a 32% chance that we are going to the beach. If the weather is good, he has a 40% chance of a hit. If it's windy or cold, he only has a 20% chance of a hit. So we're trying to find the chance of a hit. Today the weather is 70% chance of being nice, 20% chance of being cold, 10% chance of being windy. Okay, so we need, for him to get a hit, we need, if the weather is good, we could say probability of good weather and hit, or bad weather and hit. So the probability of being a good weather is 70%. And if it's good weather, his chance of getting a hit is 40%. So the probability of being good weather and getting a hit is multiplying these, that's 28%. Or, and or means plus, it could be bad weather, and today it looks like it's 30% chance bad weather. And if it's bad weather, he has a 20% chance of getting a hit. We multiply 0.3 and 0.2, that's 0.06. So if we add these two together, his chance of getting a hit today is 0.34, 34% chance of getting a hit. That's pretty good, a 340 batting average. Okay. This one, if your assignment's finished, you have an 80% chance of getting a good grade. If it's done in class or late, you only have a 50% chance of a good grade. If it's not done at all, only a 5% chance of a good grade. So here's what happens. If we're going to pick a student at random, what's the probability he has a good grade? Okay, well, how could he possibly have a good grade? He could have it finished, we'll say that's F, and have a good grade, we'll call that G, good grade. Or he could have it not finished, like done in class, we'll call that C, and have a good grade. Or he could not have it done, we'll call that N, and still somehow pull off a good grade. These are the possibilities for a good grade. So if his assignment is finished, there's an 80% chance. If we pull somebody, what's the probability that he's got his assignment done? That is 80% chance. Oh, no, that's not true. There are only 50% of the students have their assignment completed. So if I pick a person at random, the probability that he has his assignment finished is 50%. And the probability, if it's finished, that he has a good grade is 80%. So the probability of finding somebody that both is finished and has a good grade is 40%, 0.4, if you multiply those two together. Okay, here, what's the probability that it's done in class? Well, that's a 40% chance that it's done in class. If it's done in class, he only has a 50% chance of a good grade. So there's a 20% chance that we get a kid who has not finished his work yet, but he's going to get a good grade. And lastly, the probability, 10% did not finish, so there's a 10% chance this kid's not done. And if he's not done, there's only a 5% chance, so that's 0.05. And if you multiply that, 0.05 times 0.10, I think that is only 0.005. He's going to move the decimal. So we've got this, and this, and that. So that is 65% chance. No, that doesn't seem right to me. I think I multiplied something wrong. Let me see, 10 times 5. Yeah, we need another 0 on here. Oops, this one. No, I have that. 0.05. We'll come back to this.